So in this problem, you've got a 3 kilogram block on top of a 7 kilogram block, and there's friction both between these two surfaces and between the 7 kilogram surface and the table. In question A, they want you to calculate the magnitude of this force necessary to maintain an acceleration of 5 meters per second squared. Okay, so for the purposes of the part A, it's reasonable to treat both blocks like they're one thing, because what's happening is you're applying a force to the 7 kilogram block and it's accelerating the whole thing as if the 3 is part of the 7. It's like the force doesn't know that there's two blocks. All it sees and feels is a 10 kilogram block that you're applying this force of friction to, right? I mean, force applied to. But there is also a force of friction acting, opposing that motion. Now, as we know, there's also gravity in the normal force, and we actually do not have to label those just because they are the only two forces. I will label them just to put them there, but hopefully you understand why they're the only two forces. It's not accelerating the vertical, so we can say that they're equal to each other, and they're not super important to label at this point. So now, looking at this problem horizontally, I'll set it up. MA equals the sum of the forces, and in the horizontal direction, we've got force, the applied force, minus the force of friction. Now, this we always know. We can always sort of blow that up and make it FF equals mu Fn. So we'll do that now. And we'll set this up as MA equals the applied force, which is our unknown, minus mu Fn. Now, I know mu, it's in the problem, it's 0.35, and I can solve for this because what I said earlier, that they're equal. So we can rearrange this and say F equals mass times acceleration plus mu, and then this is just going to equal, we're going to write it here, this is just going to equal Fn is just going to equal Fg, which just equals mg. So then putting that together, we can say mg, mu mg. So let's plug everything in. Now remember, we're analyzing this free body diagram, so my mass is 10. My acceleration is 5, plus my mu is 0.35, and then 10, and then 9.8. And if you put all that together, you get an answer of 84.3 newtons. So for part B, it's slightly different. In the first case, we were applying a force to the 7 kilogram block, and it was pulling the whole system along. But in the second part of this, we just want to know what's the coefficient of friction that has to exist between the 3 and the 7 in order for it to accelerate along. So for part B, we're only going to look at the free body diagram of the 3 kilogram block. So if you think about this, you ask yourself, what is the actual force accelerating this mass? And you can see that the F is not actually touching. This is not actually touching the 3 kilogram block, so it's not. Think about it like this. If the 7 kilogram block and the 3 kilogram block were made out of ice and you yanked the 7 one quickly, there would be nothing to cause this to move. The 3 kilogram block has inertia and it would just stay where it is. So the only reason the 3 kilogram block actually accelerates is because of the force of friction. And in this case, it's static friction. You're trying to keep the 3 kilogram block stationary or static relative to the 7. The 7 one wants to go this way. The 3 kilogram wants to stay where it is. So in a way, you can say the 3 kilogram wants to move this way compared to the 7. And then the friction is opposing that. And the whole thing, we know, is accelerating at 5 meters per second squared. So now when we do our analysis, we're going to say MA equals the sum of the forces. So the sum of the forces is equal to just the force of static friction. So we can say MA equals mu Fn. And so we want mu, and that's just going to equal mass, which is 3, times the acceleration, which is 5, divided by, now the normal force, again, there's only two forces involved, so we're going to say this is just equal to Fg, which equals 3 times 9.8 because of the fact that it's only the 3 kilogram block we're looking at. So really we're doing MA divided by MG, which is 3 divided by 9.8. So our answer mu is going to equal, basically it's 5 divided by 9.8, and the answer is 0.51. No units because mu is unitless. So that's the answer to our question.